Welcome to Teja Statistics. In this class, we are going to discuss about the F test for equality of population variances. The equality of population variances of two populations can be tested with the help of the F test for two population variances. Example, an economist may want to test the whether the variability in income differ in two populations. Similarly, another example, quantity controller may want to test whether the quality of the product is changing over a time. Okay, assumptions for the conducting the F test. The population from which the samples are drawn must be normally distributed. The samples must be independent from each other. The variances within each group should be equal for all groups, that is sigma 1 square is equals to sigma 2 square is equals to and so on sigma k square. Let x1 x2 x3 and so on xn1 be the a random sample of size n1 from normal population with mean mu1 and variance sigma 1 square. Similarly, y1, y2, y3 and so on yn2 be another random sample of size n2 from a normal population with mean mu2 and variance sigma 2 square. So here the null hypothesis is there is no significant difference between the population variances, that is h naught sigma 1 square is equals to sigma 2 square, no difference statement. Next, coming to the alternative hypothesis, there is a significant difference between the population variances, that is not equals to either it may be the right tail or it may be the left tail. Level of significance, consider alpha level of significance with n minus 1 comma n2 minus 1 degrees of freedom. Now the test statistic. In general, what is F test statistic or what is F calculated? How the F statistic is defined? It is completely defined on the chi-square random variables. Okay, it is a ratio of chi-square of two random variables. Let s1 square comma s2 square be the sample variances by chi-square distribution n1 s1 square divided by sigma 1 square and n2 s2 square divided by sigma 2 square, or two chi-square random variables with the degrees of freedom n minus 1 comma n1 minus 1 comma n2 minus 1. F statistic is defined the ratio of these two. Okay, the test statistic under h naught we can write if sigma 1 square is equals to sigma 2 square, then both are gets cancelled, then it will become like this. So here it is supposed to capital S1 square divided by capital S2 square, right? So conclusion, what is our conclusion? Here F calculated value is greater than the F tabulated value, then we are going to reject h naught, otherwise it is accept. Okay, so very important note of F distribution, that is if capital S1 square is greater than or equals to S2 square, then F calculated can be written as S1 square divided by S2 square with the follows n1 minus 1 comma n2 minus 1 degrees of freedom. Similarly, another note, that is s2 square is greater than or equals to s1 square. This is very important. Then the flexibility in F calculated is, that is F calculated will become s2 square divided by s1 square. So according to that, the degrees of freedom also will be the change n2 minus 1 comma n1 minus 1. Okay, let's see some more examples or applications of this F distribution or F test. where it is going to be applied. It is used for testing the equality of many populations means, and it is used for comparing the sample variances. It is used for performing analysis of variance. Yes, it is used for testing the linearity of regression. It is used for determining whether the ratio of incrementally changes from the unity at any level chosen randomly. These are all some applications of F statistic. Very important, or F test. Where is F test is going to be applied? Okay. So F test can be applied in comparing two variances. Okay, comparing of two variances, very important. Thank you.